Well, as we start out here with our very first lesson of this class, what we're going to do is go with the very basic foundations of algebra, and that is solving equations. And so here, specifically starting out here in sections 1.6 and 1.7, our whole goal when we're solving equations is like what we said right here on this first point. The goal is to isolate the variable and determine what the variable represents. So if you had something simple, like x plus 1 equals 3. So what it's saying is, what do you have to add to 1 to get to 3? Well, obviously in this case, x has to be 2, something very simple like that. So that's the whole goal of sections 1.6 and 1.7, is trying to identify what the variable is going to represent. What does it mean in terms of this equation? Okay, we'll look into the next point, just some key ideas to think about as we're going throughout this simple process of solving equations. Is if there are any fractions in your equation, you want to multiply all the terms on both sides. That's the key. Or in other words, we want to multiply the whole entire equation, both sides, by the LCD. Okay, remember what an LCD is? That's just the least common denominator. It's the largest number that all the denominators will divide into. So if you had, let's say, the numbers 3, 4, and let's say 6, okay? Well, the LCD is just a number that all three of those will divide into. So obviously in this case, the LCD would be 12, okay? And when in doubt, let's say I went up there and I changed one of those, let's say to a 5. From a 6, let's say we change that to a 5. How would that change? Okay, so it's like between 3, 4, and 5, give me something that for sure that all three of those would divide into. And sometimes when you can't really, it's not obvious, when in doubt, if it's not obvious, just multiply the numbers together. So 3 times 4 is 12, and 12 times 5 is 60. So we could make the LCD be 60, and that would be fine. It's going to work either way. It's just sometimes it's a little less having to do a lot of multiplication as much, at least if you go with the least common denominator as opposed to just any common denominator. Okay, moving on to this next point is if just take note that if you have a square root in your equation, if you have fractions, you want to eliminate the fractions. If you have a square root, we want to eliminate it as well. But before we can eliminate it, the key is we need to isolate the square root on one side of the equal sign, and then we're going to square both sides. I know y'all are great when you're like, ooh, I see square root, want to square it to get rid of it. Well, first we have to isolate the square root first. It makes it a lot easier when you get your algebra skills. Okay, so let's take these points and go to example number 1. Here in example 1, we're just solving a basic one-level linear equation. Our goal is to get x by itself, and so we think, okay, I need to focus on trying to get that variable all alone, and the first thing we want to do is just think, if anything's on the side I don't need, let's get rid of it. Well, we have a plus 4 right there, so let's get rid of it. It's a positive 4, and the opposite of adding a 4 is subtracting a 4. Guys, I'm going to go through this kind of very simple just to kind of get this back in our brain. So hopefully you're just sitting there going, wow, this is really simple. But that's okay. We can go simple just to get started with. And so 2 minus 4 is negative 2. And then last but not least, just to get x all by itself, is we want to get rid of the coefficient in the front. Since 3 is multiplied to x, it's not like added or subtracted, it's multiplied. To break multiplication, we do division. So x is equal to a negative 2/3. And that would be our answer. Now we have this option because with any kind of equation like this, we can always check our answer. So going back, we're going to take what we think our answer is, and we're going to plug it into our original equation and check it out. So 3 times a negative 2/3 plus 4 should equal 2. So let's see if we can get a 2. Well, 3 times a negative 2/3, remember this is just like saying 3 over 1 times negative 2 over 3. Okay? So the 3's would cancel out, or if you wanted to, you can multiply across the top and get negative 6, but it's going to reduce, and you'll get negative 2 plus 4 equals 2. Well, negative 2 plus 4 is 2, and 2 equals 2, so we can definitely check off with that. All right, so let's take this kind of exact same point. Let's go to example number 2. In this one, right away, the first thing I see are these fractions right here, and that's where we're going to come with that first bullet. The first bullet says, or up above, where it says if you have fractions in your equation, our whole goal is to try to eliminate those fractions. So let's pick out the LCD. Between 3 and 4, what's the smallest number they divide into? Obviously, it's going to be 12. So what I want to do, and it tells me up there, is I want to multiply every single term by 12. Okay, so that first term is 1/3 k. So I'm going to go 12, or 12 over 1, times 1/3 k. Now the next term is that plus 1, so I want to go 12 times the 1. Okay, on the right side, so I have to make sure I do everything, I'm going to do 12 over 1 times that first term, which is 1/4 k, and 12 times 2. So when we look at this, really to understand how many times I have to multiply 12, you have to count your terms. Here's 1, 2, 3, and 4 terms. Just remember, your plus and minus signs are what separate terms. Okay, let's go back and finish solving this out. So 3 into 12 is 4, and that will leave a 4k right there. 12 times 1 is 12. 4 into 12 is 3. That'll leave me with 3k minus 24. Right there. That, I know I did a great job with at least multiplying through by my LCD and using the correct LCD, because everything at this point has no more fractions. And that should always happen. If you chose the correct LCD, everything should drop down and make it all just a nice one level term. Okay, at this step, all we want to do is just group all of our variables onto one side so we can isolate them and throw everything else. I just naturally tend to group all of my variables onto the left side so I can get just like k equals. And so what I'm going to do is move the 3k's over by subtracting them. So I'm going to go minus 3k, and then I want to be able to move, and that's going to take that off, and I want to move the constant over to the right. So I'm going to subtract that. So we're going to do kind of two at once. So 4k minus 3k is k. Those 12 minus 12 is 0. 3k minus 3k is 0. And a negative 24 and a negative 12, being careful here with my signs, will be a negative 36. Okay, so like what we did example 1, let's go through and check our answer. If I have k equals negative 36, let's see what happens here. So 1/3 times a negative 36 plus 1 should equal 1/4 times the negative 36 plus or minus 2. Okay, well, 1/3 of 36. How many times does 3 go into 36? 12 times. And a positive and a negative will make it a negative. 1/4 of 36 is 9, and it'll be negative 9, so we have opposite signs. So negative 12 plus 1 is negative 11. Negative 9 minus 2 is negative 11. Checks out, so we have the correct answer. All right, let's go to another example. Here in example 3, we're solving an equation. We've got x's scattered throughout it, we've got fractions, we've got all kinds of stuff. Well, the first thing I think of before I even want to clear my fractions is I look at this numerator right over here on the right, and I see, well, we can at least distribute some stuff out there. So I'm going to keep everything over here on the left the way it is. All I'm going to do is just rewrite that numerator over here on the right so it kind of matches the same style what's going on that left side. And making sure I distribute 7 to both terms, not just 7x plus 3, it's 7x plus 21. Okay, and from there, what we want to do is just focus on getting rid of those fractions first of all. So between 3, 4, and 10, what is the smallest number that all those divide into? Well, worst comes to shove, you can multiply them together, and that would give you 120. But let's see if we can think smaller. How about, let's say, would 60 work? 3 goes into 60 20 times, 4 goes into 60 4 times, and then of course 10 goes into 60. So there we go. We have an LCD that's 60. So what that means, let me see if I can just go ahead and write this in here. I'm going to take each of these fractions and multiply them by 60 or 60 over 1, so that way we can reduce. Okay, and that'll just kind of keep me from having to go through and rewrite this whole thing just to show that one step. Okay, so let's reduce first. I don't really want to multiply 60 in. So the whole goal is to get rid of these fractions. So let's go with this getting rid part. 3 into 60 is 20. 4 into 60, I said, is 15. Of course, 10 into 60 is 6. All right, so now all my denominators are now 1s, and what's left over, I'll write it like this first of all, is 20 times 2x minus 1 plus 15 times 3x plus 4 is equal to 6 times 7x plus 21. All right, look, everything's now one level. So all we have to do is just distribute in each 3 of these parentheses, group all my x's to the left, my constants to the right, and we can call this problem finished. So distributing 20, we'll get 40x minus 20 plus, 15 times 3 would be 45x plus, and 15 times 4 is 60. is equal to 42x plus, and let's see, 6 and 126. Okay, well let's see. On the left side we now have some terms we can combine together before we start grouping all the x's on one side. So 40 and 45 would be 85x, a negative 20 and a 60 would be plus 40. And then we have that right side. All right, now it looks like we're ready to start grouping. So let's move the 42x's off that right. We'll put them over to the left, and then we'll also subtract the constant off the left and put it on the right. Okay, so 85 minus 42 will just leave us, let's see, with 43x, 40 minus 40, 42 minus 42, and 126 minus 40 will give us an answer there on the right of 86. Okay, so we have 43x is equal to 86, just dividing off that coefficient because it's multiplied to the variable. Any way you want to break multiplication, you use division, and 43 and 86 comes out to a perfect 2. So there's our answer. All right, let's try another one.